Welcome everyone. Good morning, good afternoon, good evening. Very excited to have you all here in this session. Understand GraphQL API, performance options, and query optimizations in AEM. I'm Jabran Asghar, Senior Software Engineer at Adobe, member of AEM engineering team. I'm also joined by Stephen Graham, Senior Software Engineer at Adobe from my team to answer your questions via chat during this session. Let's get started. As you can see, we have quite a packed agenda, and we shall go through a number of topics, from refreshing headless context to fine-tuning GraphQL queries for maximum performance. So let's warm up a bit by taking a look at headless context and persisted queries. AEM GraphQL API goes a step further than traditional full-stack and hybrid solutions. It provides a more focused solution for channel-neutral, reusable fragments and their cross-channel delivery. AEM GraphQL API enables you to use your content fragments in a headless manner, and this on the top of existing AEM workflows that you already know. AEM has multiple tenants, also known as multiple configurations. If you look at the diagram, each tenant, for example, global, tenant 0, etc., has a set of assigned resources. These include, for today's discussion, content fragment models, persisted queries, and content fragments. In addition, each tenant has an assigned endpoint, which provides access to these resources via GraphQL queries. Global tenant is special as it has access to content fragment models and content fragments from all other tenants. For example, using endpoint of the global tenant, you can also query content fragment of tenant 0 and tenant n. Note though that the persisted queries are always stored relevant to a tenant. This means global tenant will not be able to access persisted queries of other tenants. Now, talking about persisted queries, let's quickly look at what they are. Persisted queries are GraphQL queries that are created via PUT request but executed via HTTP GET instead of POST, and their results are cacheable. The persisted query API has simple 3 steps. You can create a persisted query, note the short path, and then execute it to get the JSON result. The additional flexibility comes with the ability to pass parameters to persisted query. For example, consider a persisted query having a parameter named slug and passed via URL using GetRequest. You shall use a semicolon to mark start of the parameter and also as a separator for multiple parameters, and encode the whole parameter string. The result, the parameters passed this way, can be used as a suffix to the persisted query URL, and therefore the results can be cached at the CDN level, giving you the power to scale your application. Before we dive into fine-tuning GraphQL queries, let's look at some interesting statistics of recent GraphQL API usage by our customers. For over 2 last weeks, on AEM Cloud Service, the combined number of GraphQL API calls was about 11.5 billion. And on AEMS, it was about 34 million calls over the same time period. Having this huge amount of API usage shows the scale of AEM GraphQL API in practice. This definitely calls for the high value for the performance tuning for our customer, that is you. So let's move on to fine-tuning GraphQL queries for performance. When using GraphQL, there are scenarios when a slow execution of a GraphQL query might not be slow due to just slowness. It might be easy to overlook the need of filtering and refining the data set that one may actually need to be rendered in client applications. Large result sets might cause performance bottlenecks at multiple levels. Consider a GraphQL query, for example, resulting in a multi-megabyte result set. This might cause a performance hit when the data is read from the underlying storage. It is processed in AEM GraphQL engine, is transferred from AEM to CDN, and then to the client application. It does not stop just there, as the client application will also need to process that large data set and render it. While the next request for the same data might be a bit faster than before due to being cached at CDN, considering we are using persisted queries, but it still might not be an optimized experience for users. This leads us to the question how you can prepare your content fragments for an optimized access via GraphQL in AEM. To benefit from the latest GraphQL performance optimizations, customers can run a procedure using Cloud Manager UI. That is to upgrade their content fragments. Further details on running the procedure are available on the Experience Lead documentation, but in a nutshell, the upgrade procedure is triggered using Cloud Manager UI. The procedure is flexible to do the upgrade on author and publish tiers separately, and it is required to benefit from the filtering enhancements that we should discuss in the next sections. So let's come to hybrid filtering. Hybrid filtering combines JCR filtering with AEM filtering. So what does this mean? Let's explore an example. Hypothetically, we might have a query containing one or more filter expressions. As content fragments can have nested references, it might be that not all filter expressions can be directly mapped to JCR expressions. And this is for technical reasons. In such cases, AEM GraphQL engine might map some of the filters directly to JCR expressions to get a reduced result set, and then apply the other filters in memory in AEM. Thus, the name hybrid filtering. This technique keeps the flexibility that GraphQL filters provide, while delegating as much of the filtering as possible to JCR. Now let's explore further the different filtering options. A quick note that all example queries that we are using here use the latest weekend project contents. First, the generic filtering with variables. For example, in the given list query for articles, you want to filter articles based on a given value for the property slug. The value for the slug variable has been defined via separate JSON, which will be passed along with the query itself. Now let's look at a more powerful example where we are passing the filter itself as a variable. Note here the filter variable type article model filter. This example will yield the same result as the previous one, but if you look closely, the whole filter is being passed as a variable. This enables you to define the filtering fields and their values dynamically, and opens up a whole new set of possibilities and flexibility for a variety of use cases. A quick note that you can use dynamic filter partially as well. This means if a filter value is an empty string, then it will be, of course, considered as an empty value. But if the parameter is missing, then its value will be considered as null in the evaluation of the filter. Now let's talk about paging for GraphQL results. You get to support for two types of paging. First, the offset-based paging. In this example, using a list query, you can specify a starting offset, and then the number of results that you want to get starting from that offset. So here you are basically fetching maximum 5 items starting from the offset 5. Let's look now at the second type of the GraphQL paging, the cursor-based paging. Cursor-based paging follows GraphQL cursor connections specification. AEM creates a special paginated type for each content fragment model, and using that, you can specify number of results you want to get after a given cursor. Note that currently we support forward pagination. When executing cursor-based pagination queries, you have start and end cursor of the page also being returned as part of the page info, and also the information if there are any next page available. So in this example, you see that the 4 items after the given cursor will be returned. For sorting GraphQL results, you can provide criteria based on the fragment fields. You can also use fields from the nested fragments to sort upon, but take into account that might cause a performance hit, as results might be sorted in memory instead of being sorted at the JCR level. As a general rule, you can consider if sorting cannot be done at the JCR level, then there might be a performance hit based on the number of items the result contains. For a web-optimized image delivery, dynamic media image URLs can now be part of JSON delivery within GraphQL results. To benefit from this, you can pass all the parameters to generate an optimized image using asset transform element in the GraphQL query. and use a special field called _dynamic URL on the image reference. This enables you to dynamically generate image renditions for JSON delivery, avoiding having to manually create and store those renditions in the repository. Here's an example of the generated URL showing some of the parameters passed via asset transform element. You can also use variables in asset transform the same way you shall use other GraphQL variables. Please note that the rendition specified this way is not stored in AEM assets. Rather, it is generated and held in cache for a short period. Also, this is a pre-release feature. You will need to enable pre-release channel on your cloud environment to test this or to use this. Let's discuss now some of the best practices around all these features to get most performant results. First, the path-based queries. You can leverage repository structure to narrow down scope of the fragments being returned. This would require that the content is partitioned or categorized appropriately. Note that the trailing slash at the end of the filter value is required for best performance, as if you would not put it, starts with operator might match many other unnecessary paths as well as, and therefore it might return more results than intended. Next, you should use filter on top level, as JCR level filtering is only for top level filters. So that gives the best performance. If you must filter based on a nested fragment field, then you can still leverage JCR filtering by providing another filter on a top level field combined with the logical AND operator. Note that if nested fragments are involved, expressions combined with an OR operator cannot be optimized. Then there are certain fields which are dynamically generated as part of GraphQL JSON result. These are mainly multi-line text fields, and for those, the values in different formats like HTML, Markdown, plain text, and JSON are always generated on the fly. So the best is to avoid filtering on those. But if you must, then at the least consider adding a top-level filter expression. For example, based on _path combined with an AND operator to reduce the size of the initial result set. Then comes the pagination, which helps splitting a large result set into multiple parts. Cursor-based pagination might perform better in terms of performance in cases where you need to iterate over the whole result set. But when reading only first few pages, offset-based pagination might be sufficient. Please do note that explicit sorting and filtering might add some performance overhead. So when using these features together, also consider the earlier recommendation about filtering and sorting. Now we come to our favorite persisted queries. What makes persisted queries much appealing is their ability to be cacheable. Therefore, prioritize their use whenever possible. When combined with variable-based filtering on the top of that, the filter as a variable-based filtering, those are quite powerful. Being cached, the results are fast delivered to your clients, and thus you also avoid putting extra load on origin. Combined with a caching strategy, persisted queries can better suit your use cases. There are different cache headers that you can tune for each persisted query, and also you can set defaults for all persisted queries on a global level via cloud environment variables. Apart from the max age, which is the normal expiration of query results in a browser or a CDN cache, stale while revalidate and stale if error headers ensure continued delivery of the available content, even if stale, in case of cache expiry or due to an error on origin. So utilize and fine-tune these headers according to your particular requirements. And yes, having all these features, you might find some more suitable than others specific to your scenario. So you can combine, and you should, where it makes sense, to optimize results for your unique use case. So let's quickly look at some of the best practices in execution in a short demo. So here I have weekend content as a sample to execute a couple of queries, and using GraphQL editor in AEM. So let's look at a simple path query first, where we are passing a path to fetch a list from an adventure list, one of the adventures. So if I execute this, I get exactly one result. So as I mentioned, the trailing slash can play an important role here if you have properly partitioned or categorized your content. For example, if I remove the trailing slash here, then executing the same query would return me more results than it was intended for. And this is due to that the content here, given this path, might match more partition content than it should. So this small adjustment might save you a lot of results from being fetched extra. Then let's look at the filter query using a top-level filter at the parent fragment. So here, this query would return an article based on title from the root fragment, and it will match the author's first and last name from the nested fragment. So I would put the variables and then execute the query. And then we get exactly one result, because this is the combination that we have in the data set. In contrast, if we switch to now an OR operator, now here we are having a title field from root fragment and doing an OR between the first or the last name in a child fragment. And here we will get multiple results because we are using an OR, and the data set has data as such to have multiple child fragments related to an article which contains a particular word that we are searching for. Then let's look at the variable operator, a query where we can pass an operator as a variable. So in this query, we are simply fetching the list of adventures which have a price lower than 1,200. So here we are passing the price operator as lower than. So if we use another operator, for example, greater or equal, and execute the query, so we get the results which have price over 1,200. And this is all using this expression and passing the operator as a parameter. Then let's see how we can use a whole filter as a variable. To start with, let's look at this simple query where we are using a one variable filter, slug, and using an expression with the value which we pass from as a query variable, as we will normally do. And we get one element, one item as a result. Now, taking this example into account, let's see how we can pass the whole filter as a parameter. So if you see this example, so here we are passing the filter itself as a variable using the slug and the expression that we originally had in the query itself. And if you see here, we have article model filter type filter variable, which would actually receive this filter as a variable. I just added an underscore path, an additional field here to differentiate from the data set that we received in the previous example, so that we see that we receive it new. So here we have the same article, but now passing the whole filter as a parameter. Now move on to pagination. So here is one query which is querying adventures by using offset-based pagination. So the offset-based pagination, here we are passing the offset and the size of the page that we intend to fetch via variable. So we see that we get 3 elements here, starting from the offset 3. In contrast, if we switch to the cursor-based pagination, then we can do the same, but this time we will do it based on a cursor rather than a given offset. So if I execute this query with cursor as an empty value, so this will use the default sort order and simply return us with the first two results, like you see here. So if I use this cursor as a starting cursor, let's say, and then I want to fetch first two results after this one, then the first result that we should receive is should be cycling, with title cycling. So I would execute this, and then we see that we have the first result as cycling, because this was after this cursor, and then of course we get the second next available adventure as well. Now let's see an interesting example to optimize web, to retrieve web optimized rendering of images based on a given asset transform parameters. So here I'm also like using a variable to just set one of the properties so that asset transform parameters can also be set via query variables, like you will use any other query variable. And secondly, we are fetching, limiting the result set to two elements, two articles only, so that we are able to evaluate it better here. So here you see, using the dynamic URL, we have received here a rendering which is horizontally and vertically flipped, like with the parameter like we have specified here. So both of these images are dynamically generated, and the rendering is according to the parameters that is here. Let's change it to flip only horizontal, and I execute the query again. So there's a slight change in the parameters here. And if we see now, the image is not flipped vertically anymore. And same is the case for the other image. So this is how you can specify simply all the asset transform parameters into your GraphQL query, and get exactly the rendering URL for the rendering that you want for your client application. So let's move back to our presentation. So then the question is, what about AEM 6.5? You guessed it. Spec 17 will include the latest GraphQL paging and filtering enhancements. So the web optimized delivery in JSON might be available in a future service pack. The service pack 17 is scheduled to be GA'd later this week. So AEM 6.5 customers, let's get ready for that. So what you can do next, but before that, let's quickly review what we have covered in this session. So keeping AEM at the core as headless CMS, today you got an overview of how to optimize headless contents delivery for your applications and clients using the latest AEM enhancements, including hybrid filtering, pagination, sorting, optimized web image delivery, and on top of that, some of the best practices for developing performant GraphQL queries. So here are some references that might be useful for you to get more details of the topic that we touched today. Also on the left side, you have the QR code and link to continue conversation about the GraphQL API performance topic. Feel free to post your comments and any questions that you might have. And with that, let me see if there are any questions that we can continue with.
Hi there, it's Shay. I do have a question for you from the audience. So Adobe reminds us to use persisted queries. As these are easily cacheable, they defeat the purpose of GraphQL though. What is the recommended strategy as of now?
Persisted queries the big plus, as we saw in the presentation also, is that they are cacheable. So what happens if you don't have a persistent query in place? So you will send a request that goes to origin, and that request response is not cached. And that means if you are trying to scale up your applications to thousands and multi-thousands of users, these all requests will go to origin. And that defeats the purpose, because the same content that will be generated again and again, the server has to generate, the AEM means publish has to generate that multiple times. So the persistent queries let you cache those results and let your application to scale to whatever limits you want. But on the other hand, like I mentioned, using the different cache headers, you can optimize the experience. Maybe you have persistent queries whose content will change after 1 hour or 1 day or 1 week. So accordingly, you can set those cache headers. And of course, setting those cache headers will let your application scale, as well as let you have the updated contents. So this is like the best combination of two strategies. Put less load on a region, cache the results, and based on the frequency of updates, you can have cache headers set so that your cache is always up to date.
Thank you for that. Another question, it's kind of a long one, so let me know if I need to repeat it. Can we retrieve dynamic images within a query that returns other data from a content model? Or are the dynamic image queries meant to run on their own, returning the images only?
So if I take this in this context that binaries are not delivered within the GraphQL results. So what you get is a dynamic media URL. Given the parameters, you will get a rendition that conforms to that those parameters. So therefore, if we say, are those dynamic queries, image queries meant to be run on their own? Yes, when you request the URL using the returned URL, when you access that URL, then that rendition is generated, not that when the GraphQL sends you the result. So I hope the question answered the question. So in short, when you receive a URL, you need to access that URL to generate the rendition. And that rendition will be on the fly. It will be cached for some time. It will not be stored anywhere like you have to store it or something.
Great, thank you. And I think that might be all the questions that have come in that haven't been answered yet. Thank you so much for your session.
Thank you, Shay. So thank you, everyone, for your time, for attending this session, and wish you a very good day ahead. Goodbye.